We're going to look at solving triangles again. In this case, we're going to see if we can use the sine law to solve this particular triangle. So again, as always, we need to draw a diagram because the diagram will help us communicate our understanding of what's actually happening in this particular problem. So let's draw our diagram, and our diagram is of a triangle. And so again, doesn't have to be to scale, it doesn't have to be a perfect diagram or whatnot, it just needs to be representative. So in this case, I've got an acute triangle with angles x, y, and z. So I'm just going to call this x, y, and z. And now that I've got my angles, I can also identify the different side lengths. So I've got side length y, side length x, and side length z. Okay. So again, capital letters are for angles, lowercase letters are for the side lengths, and that's always the opposite side of the angle. So in this particular situation, it tells us that angle x is 65 degrees. So let's put in 65 degrees. It tells us that side length x is 14 centimeters. It tells us that side length y is 9 centimeters. Okay, and now it's telling us to solve the triangle. So what am I missing? Well, I'm missing a couple of things. I don't know what angle y is. I don't know what angle z is. And I also don't know the length of z. Okay, so those are the three things that I am missing. Those are the three things that I need to use to try and solve this particular problem. Okay, and if I can do that, then I'll be in good stead. So first thing I need to know is that I do have, I can use rather, the sine law. And I can use the sine law because I actually have an angle side length pairing. Without that angle side length pairing, I could not use the sine law, but I do have it, so sine law is fair game. So most information that I can get at this point is actually from the fact that I have the length of y, but I don't know the angle of y. So that's the first thing that I'm going to use to figure out, because I have no information at all at this point about either angle z or the length of z, but I do know something about y. So I'm going to try now and solve for angle y. So with angle y, I know that I've got x over sine x is equal to y over sine y. And I can use the sine law in order to solve for angle y. So I'm going to substitute in the values that I know. So I know that x is 14. I know that the angle x is 65. I know that the length of y is 9 centimeters, but I don't know what the angle for y is. So I'm just going to leave that as sine y, and that's what I'm going to try and figure out. So I've got a proportion here. I've got two ratios that are equal to each other. That means that I can cross multiply. So I'm going to do 14 times sine y and 9 times sine 65. So I've got 9 times sine 65 degrees is equal to 14 times sine y. So I want to get sine y all by itself, and in order to do that, right now sine y is being multiplied by 14, so the opposite operation is actually to divide both sides by 14. So I'm going to divide both sides by 14. And so on the right-hand side, I'm going to be left with sine y, because 14 divided by 14 is 1. 1 times sine y is just sine y. So now I want to figure out, well, what does the left-hand side of that thing equal? So y times sine 65 divided by 14 is going to be 0.5826 approximately. Okay, so now I got to figure out, okay, well, what is y? I got to get y all by itself. And right now y is being affected by the sine piece. So the opposite operation of sine is sine inverse. So I'm going to do sine inverse on both sides. Okay, so sine inverse of 0.5826 is equal to sine inverse of sine y. Okay, and again, sine inverse and sine are going to cross each other out, so I'm just going to be left with angle y on the right-hand side. And if I do inverse sine of 0.5826, it's going to give me, I'm going to round that up to 36 degrees. Okay, so now I know 36 degrees. So now I know what angle y is equal to. Okay, and so I'm going to go up to the top here. So I know now that angle y is 36 degrees. So if angle y is 36 degrees, I now have enough information actually to figure out what angle z is. Okay, angle z is going to be 180 degrees minus the other two angles, okay? Because all three angles must add up to 180 degrees. So if I have 180 degrees and I subtract the other two angles, I must be left with the third angle. So 180 minus 65 minus 36 is going to give me 79. Okay, so that means that angle Z is 79 degrees. Okay, and if this is 79 degrees, now I actually have enough information to solve for side length Z. Okay, so I'm going to go back to my original key of X, and then I'm going to use that to solve for Z. So now that I know that Z is equal to 79 degrees, okay, I'm going to solve this on the right-hand side, and I'll solve this one in blue, just because I can. So I've got x over sine x is equal to z over sine z. Okay, because all three ratios are equal to each other in the sine law, I can write it this way. So I know that x is equal to 14 centimeters. I know that the angle for x is 65 degrees. I don't know the length of z, but I do now know the angle. We just solved for that, okay? And so the angle for sine z, or the angle for z rather, is 79 degrees. So, just like we do, we have to cross multiply. So I'm going to take 14 times sine 79 and z times sine 65. So I've got 14 times sine 79 is equal, let me try that piece again, is equal to z times sine 65 degrees. Okay. Now I want to get that z piece all by itself. Z is right now being multiplied by sine 65. So the opposite of multiplying by sine 65 is, of course, dividing by sine 65. So I'm going to divide both sides by sine 65. Sine 65 divided by sine 65 on the right-hand side, the equal sign, is going to cancel those two things out. So that's just going to leave me with the length of z. And if I calculate what's on the left-hand side, I've got 14 times sine 79 divided by sine 65. And that's going to leave me with approximately 15.2. So z is equal to approximately 15.2 units long. So 15.2 centimeters. So now what I've been able to do Using the sine law, as well as understanding that all three inside angles of a triangle equal 180 degrees, is I have solved this triangle. So I now know the length of all three sides, and I know the value of all three angles of this triangle.